So thank you for attending this morning. It was the first session of the day for you, so we'll definitely keep it interesting. So I'm Leo Zhadanovsky. I'm a solutions architect at Amazon Web Services. I have worked with our education customers, and I currently work on the international expansion team. And so today I will be talking about the AWS developer tools, so all of our code tools, Cloud9, CodeStar, and then I'll let Tom Creighton introduce himself and what he'll be talking about.
I'm Tom Creighton, CTO and lead architect for Family Search, and I'll be talking about our journey to DevOps as opposed to the journey to cloud, although they happened about the same time. So,
great. All right, so we are here today to talk about, first we'll just define what DevOps means in the context of this talk. So DevOps is kind of a buzzword these days, so we'll make sure that we define it. We'll talk about our code services, so code deploy, code commit, code build, code pipeline. And I will also just talk about our larger DevOps portfolio when it comes to our monitoring, logging services, and deployment services, and so on. And then Tom's going to talk about DevOps at Family Search. So why is DevOps even important, right? So software moves really fast today. So your ability to quickly build and release and get software in the hands of your customers, whoever they may be, is really important. And it might be the difference between somebody who's, somebody succeeding in their field, right? So according to the 2017 State of the DevOps report, which is put on by Puppet Labs, you can download it there. DevOps means that you will have a lower failure rate when you do deployments. You will have a much faster time from committing code to a source code repository to actually deploying that code in production. You're going to have much more frequent deployments, and you'll be able to spend more time on actually building features and code and less time on debugging and undifferentiated heavy lifting. So DevOps has really three components in it. There's the cultural part of DevOps. There's the actual practices that you do as part of adopting DevOps. And there's the tools that you use to allow you to do those practices. So let's talk about the culture first. DevOps at its core really means your dev teams and your op teams coming together and not being in a silo anymore. So traditionally, you've got your developers working on code. They build the code. They throw it over the wall to ops. Ops deploys the code. There's some disadvantages to that. So what that means is that your developers who are building the code, they have little to no idea to how their code is deployed, how the system that they're deploying onto is architected, what are the consequences of building things a certain way. And the operations team, to them, they're deploying a black box. They don't know what they're deploying, and if there's an issue, you've got people pointing fingers at each other, and a lot of other problems. So when you do DevOps, you really combine the two. What that actually means depends on who's doing it. Some customers have a DevOps team that does, builds common tooling for the whole organization. Some customers, each team is kind of separate and does its own deployment, and you've got people who are ops focused and people who are dev focused, but they're on the same team. So that can vary among customers. But what it ultimately means is you've got shared responsibility. So ideally, you've got one group of people who are responsible for building the code, testing the code, deploying the code, and maintaining it after it's already running. So that way, when something goes wrong, everybody is invested in fixing it. So you've got ownership of every product by everybody on your team. And to do that successfully, you need to make sure that there's good visibility and communication across the team. So what that means is having good logging means that doing something with those logs, so picking out the metrics that matter and alerting on them and making sure that when your app gets slow or something's broken, you don't find out from a report from a user of your code, you find out from your metrics and get ahead of it. And in terms of communication, it means having a good remote team kind of setup if you have that. So using something like Slack or AWS Chime or HipChat. So making sure that everybody in your team knows what's going on all the time. So let's talk about some other things that we see in the industry as customers move to DevOps. The first is we see a move away from big monolithic architectures and a move to microservices. So what that means is that instead of having like one giant server that has your app and your database and everything on it, and it's built to be really redundant, you instead break your application into small pieces. Those small pieces each do one thing really well, and they're all independently scalable. They're all built in parallel, so you can swap out the underlying language architecture of any one of these microservices, and as long as they stick to their published API, it doesn't really matter because the other services that are consuming them are just talking to the API. And so you have loose coupling between these services. We also see a move toward continuous integration and also continuous delivery and deployment. So we'll talk about what that actually means in a second. And then we see a move to infrastructure as code. So a lot of our customers have been, doing things like Chef or Puppet or Ansible for a while for their actual, what's on the operating system of their servers. But infrastructure as code extends that philosophy to your load balancers, your databases, your actual infrastructure. What would have been physical hardware before, you can now control with code. So for AWS, that means usually using CloudFormation. So CloudFormation is a service that we have where you can have a JSON or YAML file, and that file defines your actual architecture, and you store it as code, and you update it as code, and so you can easily reproduce environments, you can easily fix things, and everything that happens programmatically because your source of truth for your architecture and your application is the CloudFormation template. So if something goes wrong, you can easily fix it. There's a lot of benefits to that. Another thing that we see is monitoring and logging. So you have to be able to, again, figure out what metrics are important to you. So for example, for a retail website that sells something, orders per second is probably a really important metric, and you can work backwards from there. So you know if your orders per second are dropping, something's wrong, and you have to fix it, right? So instead of focusing on things like individual CPU usage, on a server, think about the more important top-level metrics for whatever it is that your application does, and measure those, and alert on them, and make sure you get use out of them. Understanding the real-time performance of your infrastructure and application. So using some kind of application monitoring system that tells you how long does this web page take to load? What are the slow loading parts of my application? If something is slow, is it because it's taking a long time to do a database query? It's not hitting the cache? What is the actual problem? So understanding these sorts of things and debugging them is really important. So just to summarize, some benefits of using DevOps. So because you're eliminating silos between Dev and Ops, you have improved collaboration between your staff. You have much quicker delivery of when code goes from being committed to a repository to being deployed in production. Because DevOps is a forcing function for automation, it also means that typically you have more reliability in your applications because there's just a whole group of errors that you make from being human, from typing in the wrong commands that you eliminate by automating things. Security. So once you have an automated CI/CD pipeline, you can build in security into that pipeline. So for example, if you're building a Docker container or an Amazon machine image every time you deploy, part of that CI/CD process could be scanning the image for vulnerable packages or running a security test against it of some kind. And so instead of scanning for issues after the fact, you can scan for security issues as part of your deployment process. Scaling. So again, because you've automated everything, going from one server or instance to multiple servers or instances should be pretty easy because you're just recreating more units of the same thing instead of manually configuring them. And speed. So the fact that you're able to scale means that you're able to speed up your application more quickly. And the fact that you have good monitoring and logging means that you're able to eliminate bottlenecks and slow points in your application. So let's take a look at the 5 major phases of releasing and monitoring your application. The first is source code, right? So this is where you check in your code into a source code repository of some kind. So in this talk, we'll assume that's Git. You do your peer review. Then you build the code. So in the build phase, you compile your code. You do your unit tests, your style checkers. You create your either container images, Amazon machine images, MSI packages, RPMs, Debian packages, whatever your unit of deployment is, you create that here. And then you've got your testing phase. So that's when you do your integration testing with other systems. You do your load testing, your security testing, your UI testing. Then you've got deployment. So you start deploying to different environments. So ultimately, you get to production, but you probably have some environments before that. So staging, development. And then lastly, after your code is up and running, now you're monitoring your code to detect unusual activity, and again, to fix errors before they become a big system-wide issue. So now let's take a look at the release level processes. So you've got continuous integration. So continuous integration is just when you use software to make sure that when you commit code to the mainline branch of your source code repository, a build of that code is triggered, and you make sure that the code is actually compilable. There's no runtime or build errors. And to do that, you can use, we have these code services I'm going to talk about. We have customers who use open source solutions such as Jenkins or partner solutions such as CloudBees. So there's a lot of things you can do there. Then you've got continuous delivery. So continuous delivery is when you have code going from source to build to test and ultimately to production, all with automation, but you have a manual gate before you get to production. So somebody has to go and hit approve before the code gets to production. And then you've got continuous deployment. So continuous deployment is when you have full automation. Your code goes from being committed to the Git repo, to being built, to being tested, to being deployed to multiple environments, ultimately ending up in production without a manual gate. So most of our customers, as they begin their DevOps journey, what they're really working towards is continuous delivery. Because that gives them most of the benefits of DevOps, of automation, but it gives them the guardrails of having a manual gate before code gets to production. And as they get there, as most of our customers get there, they start achieving excellence in their CI/CD processes and confidence that it works. And so at that point, they may decide, well, this specific microservice, we feel confident with doing continuous deployment on it. We don't need a manual gate. And then some of them eventually move that to most or all of their processes. And some of them never do. They just stay at continuous delivery, and that's fine. It just depends on your appetite for risk, how you feel about the strength of your deployment processes, and several other things. So let's talk about code services. So first of all, for monitoring, we're going to just touch lightly on those in this talk, but we've got AWS X-Ray and CloudWatch. So X-Ray is our tracing service, and CloudWatch is our logging and metrics service. For source code, we've got a service called AWS Code Commit. For building your code, we've got a service called Code Build. For testing your code, you can also use Code Build for unit testing. For integration testing, UI testing, security testing, you probably want to use a third-party service at this point. And for deployments, we've got a service called CodeDeploy. We've also got other services that you can use to deploy, such as Elastic Beanstalk and OpsWorks, but we won't really cover those in this talk. We're going to talk about CodeDeploy. So, and then we've got Code Pipeline. So Code Pipeline is our continuous delivery service that moves you along from different software release steps. And it works with third-party software as well. And then we've got CodeStar. So CodeStar allows you to quickly start from a pre-built template. So let's say you want a LAMP stack. It's going to pick and choose a certain subset of these services and get you a pre-built environment really quickly. So if your developers just need to try some of these services out, start testing, they can use CodeStar for that. It also has integration with our Cloud9 ID, which I'll talk about, and several other nice features. So then we've got our larger DevOps portfolio. So for this, we talk about the code services. Again, for infrastructure as code, we've got OpsWorks, which is like automated chef or managed chef, and we've got CloudFormation. And then for monitoring, we've got X-Ray, CloudWatch, CloudTrail, which allows you to monitor your AWS API activity, and Config, which allows you to monitor the state of your account over time. So let's dive into these services. So first, we've got Code Build. So code build is a fully managed build service. So it takes code, it compiles that code, runs tests, and produces software packages. It is built in the background on Docker containers. So it spins up a Docker container. You can do multiple parallel processes at the same time, parallel builds. You can either use a pre-built build environment that we provide for you. So we have some common ones such as Java, Python, so on and so forth. Or you can just bring your own Docker container. So if you're using something that our pre-built environments don't cover, you can just bring your own Docker container with your own build environment. You pay only by the minute for the service, and it comes with Code Pipeline and Jenkins integration. So you can just enable the Jenkins plugin if that's what you're using and start using code build today. So how does it work? It downloads the source code of your application. It executes whatever commands you tell it to, and that you configure those in a build spec file, which I'll show you in a second. It streams the build output both to the console and to our CloudWatch logs, so you have a record of it. And it uploads the generated artifact to an S3 bucket. You can also have it, if you're doing Docker container, upload it to Docker Hub or our container registry as well. So again, it allows you to automate your release process because it's API and CLI driven. It's got integration with Code Pipeline and Jenkins, and you can use your own build environment. So it has a build spec file. So this is what controls it. It's a YAML file. In this file, you tell it basically what commands to run. Again, I know I'm going pretty fast here, and there's a lot of slides. So these slides will be available afterwards, by the way. So you can take a look into them then. So now let's talk about, I'm going to skip this part, actually. And let's talk about testing your code. So again, for testing your code, what you're really going for is eliminating syntax errors, confirming desired functionality, standardizing code patterns, and making your applications more secure. So according to industry experts, you should focus 70% of your testing on unit testing, 20% on service testing, 10% on UI testing. So for the unit testing, you can use code build. For the service and UI testing, you want to use third-party tooling. In terms of pricing, you pay by the minute. It depends on what size container you have it spin up, and you get a complimentary tier of 100 build minutes per month that are free on a new AWS account. So let's talk about deploying your applications. So we got CodeDeploy. So CodeDeploy handles code deployments to any instance. It can work on EC2. It works on ECS now as well, or actually no, on Lambda. You can use it to deploy to Lambda. It does rolling deployments. It can do blue-green deployments. So you can have it set up different deployment scenarios. And it works with on-premise servers as well. It integrates with a third-party tooling and AWS. So just like there's a build spec file in code build, there's an app spec file in code deploy. This defines where to copy the files in the package, how to set the permissions on those files, and how to configure, how to do the actual deployment. So that's done through a bunch of scripts. You can either do shell scripts, such as in this example, but it works with any executable. So you can actually get it to trigger your Ansible playbooks, for example, if you want, or run some executable. So you can choose the deployment speed, so you can deploy it to all your instances at a time, some of them at a time. You can deploy based on tags or auto-scaling groups as well. Let's talk about Code Pipeline. So Code Pipeline is a continuous delivery service. It allows you to model and visualize your software release process, and it is what triggers code build, code commit, code deploy, and third-party services as well. So here's an example pipeline. In this case, we have our source code in GitHub. We have a build going on code build, and we're deploying using Elastic Beanstalk. So this whole thing is a pipeline. There's 3 stages here. We've got a source stage, a build stage, and a deploy stage. And then each stage has 1 or more actions. So you can have, and then there's transitions between stages when one stage is done and transitions to another. So you can have parallel actions. So in this case, we're building code, and we have a Lambda function that notifies our developers in Slack that there's a build going on. You can have continuous functions. So then after that's done, you can have a test an API using a third-party service, such as runscope. And we've got manual approvals. So again, if you're doing continuous delivery, you can have it, you can insert a manual approval before you get to production or at any other point that you need to. So now let's look at code commit. So code commit is our managed Git service. It is built on top of S3, DynamoDB, and KMS. It has functionality for post-commit hooks, so you can get it to trigger a Lambda function after a commit has happened. It is encrypted at rest with our key management system. So the way that you interact with it is just a standard Git experience, but in the background, again, it's using those 3 services. And so this is what it looks like using it. So again, in here, I'm just cloning a Git repo. I'm editing a README file. I'm committing changes to that file. It's the same thing as using any other Git. The pricing, so code commit is $1 per active user per month, and there's a storage fee too. The first 5 users are free. Code pipeline is $1 per active pipeline per month, with the first pipeline is free, and the first 30 days of any pipeline are free. So if you're just testing, it's not going to cost you anything until a month in. CodeDeploy is free for EC2 or Lambda, and there's a fee per update for on-premise servers. And then code build, again, it's per minute. So let's quickly go through CodeStar and Cloud9 and X-Ray, and then I'll hand it over to Tom. So, okay, CodeStar is a service that allows you to quickly develop, build applications on AWS. It works with multiple people on a team. So you choose a template. So these are just some of the sample templates that we have. You select where the source code is. Right now it supports GitHub or code commit. You pick, depending on the template, it chooses different services to pre-configure for you. You pick how you want to edit your code, so you can do that with our Visual Studio plugins, our Eclipse plugins, our command line tools, or our Cloud9 Cloud IDE. And then you can set up different access for different members of your team, so you can give them either just read-only access or write access. And it gives you a unified dashboard, so you can then see the code pipeline that's spun up. You can connect it to your Jira, so you can keep track of all your issues, and it's got a wiki tile as well. It also shows you the monitoring for your application, the endpoint, and the commit history. So go take a look and play around with that. So X-Ray. So X-Ray, I'm going to skip some of these slides here, but basically, X-Ray is a managed tracing service. So it allows you to identify bottlenecks in your code, pinpoint specific issues, and identify an impact to users. It also works off cloud. It allows you to, you can integrate it with your application via the API. It supports different languages. So what it does is allows you to trace requests, record those traces. It maps out your service, and what the latencies are between different microservices in your application. It allows you to analyze those issues. So the way that it works is you've got your X-Ray console, and you use the X-Ray SDK in your application to report to the API, and that all gets displayed on the console. So the last thing I'm going to talk about here is Cloud9. So Cloud9, I see there's a typo on this slide. It's OK. It's cloud, not bloud. So it is a cloud-based IDE. It allows you to write, run, and debug your code in just a web browser. So you can have a Chromebook or an iPad or something that's not a powerful development environment, and you can still have a really nice IDE on there. It gives you direct terminal access to AWS, so it has a terminal tile, so you can run CLI commands in there. It allows you to share your environment with your team, so if you have another IM user, you can just share it with them. And it provides a really great experience for serverless editing. So if you have a Lambda-based application or using API gateway, it allows you to actually simulate those Lambda functions before deploying them to the actual service. So again, it's a fully featured editor. It's got code hinting, autocomplete, tab completion, all kinds of nice features there. It has a bunch of different runtimes built in. It has a fully featured debugger. It's got, again, integration with our serverless stack. So you can simulate API gateway locally. You can simulate Lambda functions locally. It's really useful for debugging Lambda functions, and we've got some labs up on our GitHub for playing around with this. And so I'm going to skip this slide here. Let's skip that slide here. And so that is a very quick overview of our code services. So now I'm going to hand it over to Tom.
Thanks a lot, Leo. It's great to be with you. And let me just preface what I'm going to say with this stuff is real. You really can do continuous delivery. I'll usually use the word continuous delivery, but in actual fact, almost everything we do is continuous deploy. So it's just the verbiage that we developed along the way. First, who are we? Family Search International is the largest and oldest genealogical society in the world. We publish billions of source records, such as you see in the upper right-hand corner. This is a picture of a census record from the United States having one of my ancestors in it. But these come from all over the world. We've been collecting them since at least the middle 20th century. Today, our collection teams are all over the world doing digital capture. In the older days, it was all on microfilm, which we now are almost finished digitizing, and that's more than 3.5 million rolls of microfilm. We do this in order to allow you to learn about your family history, who you are, who you people are. And so while we do support professional genealogists, our real target is people like you and me, and I am not a genealogist. I was hired as a computer scientist, so that's nothing to do with genealogy there, but it's an interesting problem. In the middle 20th century, our sponsoring organization, the Church of Jesus Christ of Latter-day Saints, who fully owns us and funds us, built a storage facility in a mountain outside of Salt Lake City. And this facility, that's where we have microfilm repository, but we also have repurposed it. We have a significant digital preservation system running in there, running tens of petabytes of storage in that facility. One of our main products is what you see on the front. This is a representation of a pedigree. We have sort of a wiki model where everybody can participate and collaborate within this. So how do we do all this? So this is what we do. How do we do it? Specifically, how do we do it relative to DevOps? Some years ago, we recognized we had lots of dysfunction in our organization. And so we realized that part of changing how we work to get the solutions we wanted involved cultural changes. Now you can decide after this talk whether we started on the right and went to the left, or we started on the left and went to the right, but I think we got better. In any case, that's part of DevOps, is changing culture. Here are some of the elements that we dealt with, or dysfunctions that we dealt with. Each team can certainly build their own build and deployment pipeline, but it requires specialists to do that on the team. So we found that that was a dysfunction. Often builds were broken. At the time, this is several years ago, most of what we had were a small series of service-based applications, but they were monoliths, right? So it's, as opposed to microservices, they were service-based. We had APIs in front of everything, but they were big, and they took a lot of effort to get to be ready to bring to production. So that was some of what we had to deal with. So here are some specifics. Each team built and deployed their own way, and that caused problems. It's fine, it's okay as long as it works, but it means that every team is responsible for having an expert in how to make that happen. By centralizing that, we reduced the friction. Everybody had to do things a certain way. We had 2 or 3 ways of doing it, but if they did it that way, everything went smoothly. And so that, creating a build and deploy pipeline, smoothed that effort out. Builds were, I say often broken. No, they were always broken. Build was always broken, right? Because we had, for example, the family tree application started off with roughly 50 developers. One application, lots of teams, one database, pushing code all the time, changing the schema all the time. This was really broken. And so solutions entailed things like all updates are small, updates go to trunk, we do pull requests to do reviews. These kind of cultural changes were necessary to make things work a lot better. We would commonly take 3 months to say we're ready to do a release. And during that 3 months, we'd have to sort of freeze commits, right? We'd have branches. So everybody's off on multiple branches. After a month, developers are going, no, what was in that trunk branch? What was in that main branch that we're trying to deliver? Because I'm like a month down the road. I can't even remember what changes were there. So it was really, and if a critical problem showed up in the current stack, oh my goodness, now what? We've got to get another branch just to fix the one bug, get that deployed, go back to, right? So it was a mess, the long release cycle. A lot of problems with consistency in development model. Everybody was doing their own thing, cool, but because of that, we had different iteration cycles. We had some people using Kanban, some using Lean. So getting consistency in how we think about development was crucial to success. And let me just say that one of our 2 mantras, and you're going to hear another one soon, is automate everything. So if you have to do it twice, you better have it automated by the 3rd time it comes up, right? So that's an important consideration. Quickly, I'm not going to go through this in detail. This is just to express that one cultural change that was crucial to us is to establish what is Family Search's development process. What do we do? How do we do it? So we established, here are the roles that we have in the organization and the responsibilities of each role, what activities happen in development, and what artifacts are developed. Now, this is cool. It works for us. Doesn't matter what it is per se, but it does matter that you're intentional about it, right? So as an organization, you need to sit down and say, let's be intentional about how we develop and get everybody on the same page. Everybody buys in on it, and then we can start to fire on all cylinders. This was crucial to our success. In addition, as I mentioned, we had some doing various sorts of Lean, Kanban, Scrum. That's okay individually, but as a large organization, it becomes very difficult to facilitate that because communication doesn't work well. If you have a product manager, product owner of multiple products, and each product team is using a different technique, it's really hard to keep track of. So we said we're going to build a Scrum-based process build, meaning we define it. And so we have one ring to rule them all, I guess, given this diagram. And then we agree on it, and then we teach it to new employees and review it over time among all of our developers. Okay, so then there's the whole dev versus ops, right? And we had build and throw it over the wall sort of mentality. And while maybe dev and ops aren't Hatfield and McCoy, not far from that, and maybe DevOps isn't exactly Little House on the Prairie, but it's a lot better, right? And so I encourage you to look into that. You really become serious about it. Let me jump into some of the tools that we use. It's rare today that we hear somebody call out, hey, who's got a 7/16 box end wrench? Well, okay, never happened, but that sort of thing. The manual tools are not nearly so common. We rarely, only in certain cases do we, for example, use the Amazon console. Everything is automated. That's outside of a playground. So we have a little playground, people can just play around. But when it comes time to really do code, everything's automated, and that's what we do on the right side. And we really want to have patterns of things. So we value, mantra number 2, we value sort of a consistent way of doing things over configuration, right? So we much prefer to have a pattern of doing things over lots of different configuration files to do it. And so that's a lot like using a jig on a bandsaw or I think they're called router patterns for routers. Do the same kind of thing the same way all the time. Okay, so a long time ago, before availability of the stuff that we just heard from Leo, we built continuous delivery, continuous deploy using tools that we could get or build ourselves. But basically, they look very similar. So we created a declarative way of describing systems and components, and systems of components. In fact, we use YAML. We call it a blueprint, and this is fundamental to how we manage all of our code. At this point, that can now be implemented using CloudFormation or other mechanisms that are available to us today. But originally we deployed our code on premise, both on VMs and raw hardware, using this technique. And then we implemented private cloud, Cloud Foundry. Now we're all in on Amazon. This year we'll get to well over 95% of everything we do is in the Amazon cloud. Next year, probably 100%. So this is a quick example, just showing, in this case, FS Platform API is the name of the component, and it needs to have a Redis cache, and there's some configurations in the Redis cache. And by the way, I'd like this deployed on Beanstalk, and it's the implication is a Tomcat stack. A little more, you can specify Java, JVM parameters, and some other things, including scaling parameters. All this then gets used by our tools that we've built to create and manage the code in Amazon. We use Electric Flow, which is you can get this as a workflow engine. Again, this year we're looking at how we can leverage the tools that Amazon have now published, but we didn't have them when we got going. This has been a pretty good tool for us and has a nice UI, so that's a good thing. So this tells us where we are in various pipelines that are running. So let's talk about pipelines. In general, pipeline consists of a set of steps. One pipeline finishes and hands off to the next pipeline until code actually is out there running in whatever environment, test, dev, production, whatever. And so we construct them for each commit or commits that happen within a short time frame. And then we deliver those changes, and we can manage failure on those, and also we have to manage the synchronization of events. So commit's pretty simple. Basically just one or a few commits within a short time frame. Git hooks happen, and we then fire off a component pipeline, which is basically our build pipeline. So we run it against every commit. The objective is to create a release candidate. That happens when we pass automated tests. These are unit tests. And a failure guards the component, saying it's got to get fixed. You got to do a new commit before it'll start this process up again. But that means you fail fast and get busy fixing it. A release candidate will kick off integration pipeline. There we throw the code out into an environment that allows us to simulate the production environment. It's usually not as scaled as production, but it does have all the pieces and parts. So we have many dozens of components that are running, microservices that are running, and they are interdependent on each other. And so we have to test this before we can say we're ready to roll. But we do these tests all in parallel. So we're deploying this code all the time and validating that. So these are more extensive testing than unit tests. For example, unit tests will mock these out. In this case, they're not mocked. It's a real live thing. But when that passes, when those gates are passed, then we start up a deploy pipeline. And the deploy pipeline will, it's the same deploy mechanism for all of our various environments. And they often will start in parallel. Now, we won't actually make the code available and deployed in production until it passes the lower tier, lower references, but the beginning of it is all in parallel. And we do it, usually we do a rolling deploy, sometimes we'll do blue-green. Again, it'll be interesting to see how we can integrate with Code Pipeline. I fully expect that we will within the next year or a little longer for the full integration. Okay, so the whole idea here is we automate everything. We keep everything is in version control. We don't keep things in our head exactly until it stays in the head long enough to get it committed into GitHub, and then and then it's remembered for us. And released is an interesting question, right? When is it released? Well, code gets released into production all the time, and final check is in production, and we make extensive use of experiments. So although we were pushing code out into prod, we'll only have a segment of our users see that at a time. When we decide that's all done, the experiment gets opened up, and then everybody sees it at once. But the code itself is already in production. Okay. This is one point I want to make on this slide is a couple. If it's not tested, it's not done, and if it's hard, we want to do it. We want to do it over and over, right? We want to do it a lot, because otherwise you don't get past the hard stuff. This is an example of how we keep track of what's going on. Here we have some 600 deploys into development. We're a couple hundred going into production and test. So it's common for us to be pushing over 1,000 commits each day, and often we'll do that many into production. But this dashboard tells us kind of by week, by day, where do we stand. And it also tells us, the little pie chart tells us where stuff's going. Most of everything we do gets pushed out into US East 1, but we also have code going out into a number of other regions. This dashboard, I understand if you don't post it to Facebook, it didn't happen. If you don't monitor it, you don't know, right? And so we do extensive monitoring. This is an example of a dashboard that we review at least weekly at a management team level to talk about what is our current availability. How do we look at that? And so we look at this all the time, and we target 3 nines of availability, which we consistently achieve. There are a few components that are actually higher than that we need to have higher than that. So I won't go into much detail, but this is done at the high level of Apica web monitoring. So that's synthetic monitoring. Leo talked about real user monitoring, although he didn't use that term. We do that as well, and I'm just going to skip past that today, right now for this talk. But we use XMatters for informing or alerting our DevOps teams of events, failures, so that they can jump on it. So DevOps means the developers who are responsible for the code that just failed, and they have a rotation that they're on for who gets called first, and then if responses aren't happening soon enough, escalation happens up the management chain. We also have, as you can see, a number of other tools that we use, some that aren't even on here. This talk is about DevOps, and so although I'm an architect, I'm restricting myself a little bit. It's hard, but just briefly though, the DevOps model does have implication about architecture, and Leo mentioned this. He said he sees many customers moving to a microservices architecture. That has good, that's both good because of sort of the operational considerations, but it's also good because of what benefits you get over in your overall architecture. We've really made the jump that direction. We still have some service-based architecture in our environment, but all of it, the applications, are all in GitHub. And then at a lower level, infrastructure architecture, how we lay out our accounts, how we lay out VPCs, that's also all in GitHub, all managed through CFNs. In fact, if a service comes out of Amazon that I can't control completely using tagging and APIs, we won't use it. So if we get, I like the wizards that we get for learning about it, but if I can't control it, it doesn't get used. So because we have to automate everything. Okay, security implications are interesting too, and I'm going to touch briefly on that. This is a console that we built. We wanted to allow developers to get into production or other environments to SSH into the servers, but they can't do this without unfettered access. I need to be able to show auditors that I've controlled my environment. It's not just open season, right? So here's how we do it. We built this little application. You come in, you say who you are. It authenticates, authorizes you to get certain access. One of the tabs on here says I want to go into the console, Amazon console. I want to do a couple of things. Mainly, I want to find out the address, IP address of a member of a scaling group, because there's something failing. I've seen it in the logs. I need to go get that. So I'm going to get Amazon credentials to let me get to the console in the environment I'm after. So we don't give credentials to all of our developers. They get it through this. And so I didn't get a slide for this, but if you press that blue button, you actually get a pop-up window that has an IAM username that was generated and credentials for that IAM user, and the roles assigned to that user is assigned to give the privileges that the person requesting needs and is authorized to get. Okay, but then they can use those credentials to go to the console, figure out the IP address, plug it into this next tab down there at the bottom, along with where I'm going to make some changes and why I want to get SSH access. We log all of this. They get then an SSH key that gets laid down on the server, the target server. They can use that to SSH in, and it's good for 24 hours. Now, at the end of 24 hours, the key expires, and so does the server. So if somebody has SSH'd into a server in production, we call it tainted, and we're going to pull that out of rotation. We're going to terminate it. And that forces whatever changes that might have happened, which we've logged, of course, that forces those changes to be put into code, into config files or into code, and checked into GitHub, and then rolled out through our deployment pipeline. Otherwise, you end up with, I don't know what, right? Somebody made changes in production. I don't know what changes were happening there. Scaling events mask that suddenly. So this is how we handle it. We force it. You're dead, right? Okay. So 2 mantras. Convention over configuration. That's very important. Don't just make configuration files change everything you do. Have patterns for doing it. I skipped past the patterns of my architecture because we don't have time, but we have 3 basic patterns for VPC layout. Automate everything. And I thank you very much. I'm not sure that we have time for questions. What does it look like?
Yeah, so if anyone has questions, we're just going to get the next speaker set up, and then I'll be in the hallway outside. And
I'll hang out too.
Yeah, and
Okay.
we'll take any questions anyone has. Thank you, everyone.